Today I want to talk about matrices and matrix operations. So what is a matrix? Well, a matrix is simply an array of P by Q elements, where P denotes the number of rows and Q the number of columns. Then we say P by Q is the dimension of the matrix. So an example, if I have this matrix right here, 1, 2, 3, 4, 5, 6, I say it is of dimension 2 by 3. In other words, 2 rows and 3 columns. By the way, your book has a tendency to write matrices with these round braces. Most other books use square brackets. Okay, a matrix is said to be square in case it has the same number of rows as columns. So the matrix 1, 2, 3, 4 is a square matrix, 2 rows and 2 columns. Get it? A square matrix is a matrix that looks like a square. All right, what can we do with matrices? And the answer is, one thing we can do is scalar multiplication. How does one multiply a matrix by a scalar? By the way, anytime I say scalar, I mean real number. Well, I claim it's common sense. How do you take a matrix like this 1, 2, 3, 4 and multiply it by a scalar 4? The answer is you multiply each individual term by the scalar. So 4 times the matrix 1, 2, 3, 4 gives us the matrix 4, 8, 12, 16. The next binary operation is matrix addition. Now, to be able to add two matrices, they have to be of the same dimension. That means they have to be of the same number of rows and columns. So if I take this matrix, 1, 4, a matrix that consists of only one row, by the way, we call a matrix like that a row matrix, get it? If I try to add the matrix, the column matrix 3, 4, I cannot do it because the dimensions don't match up. You have to have the same number of rows as columns. But if I take the row matrix 1, 4 and add the row matrix minus 1, 2, they both have one row, 2 columns. I can add those. How do I do that? And the answer is you add them term-wise. So it's going to be 1 add a minus 1 and a 4 add a 2. So I end up with another row matrix 0, 6. I can combine those two concepts. I can take a matrix and add or subtract a multiple of another matrix just by doing what I'm going to claim is the natural thing. So you take the 1 and add the minus 2 times minus 1. That's what you get in the first slot. And then you take the 4 and add the minus 2 times 2. And when you do that, you get the matrix 3, 0. So how do you add corresponding matrices? The answer is you add each component. Another example might be if I take the matrix 1, 2, 0, 3 and add 2 times the matrix minus 1, 1, 0, 2, I get 1 add 2 times minus 1. So 1 subtract 2, that gives me a minus 1. 2 add 2 times 1, that gives me a 4. 0 add 2 times 0, that gives me a 0. 3 add 2 times 2, and that gives me a 7. All right, so that's matrix addition mixed with scalar multiplication. Finally, matrix multiplication. How can I take two matrices and multiply them together? The answer is, the only way I can do that is if the number of columns on the first matrix is the number of rows on the second matrix. So if the first matrix is of dimension p by q, the second matrix is of dimension q by r, then since these two numbers match up, I can multiply them and I get a matrix of dimension p by r. So it's got the same number of rows as the first matrix and the same number of columns as the second. All right, and how does that happen? How do I do that? Well, the easiest example is to have a row matrix and multiply it by a column matrix. So here I have a 1 by 2. I'm going to multiply it by a 2 by 1. Since these numbers here match up, I have 2 columns in the first and 2 rows in the second. I can do this multiplication, and what am I going to have as a result? A 1 by 1. So that's why this is the easiest example. It's going to be a matrix with only one entry. All right, what is that entry? Well, the rule is you multiply successive parts and add them. So it's going to be a 1 times a 3, add a 2 times a 4. So 1 times 3, add 2 times 4. That's going to give me the number 11. So in fact, that's the way you take a row matrix and multiply by a column matrix. You multiply the corresponding elements, first element in the row times the first element in the column, add the second element in the row times the second element in the column. And then, like I said, you add those two together. All right, how do you generalize that? And the answer is you generalize it by multiplying a particular row by a particular column. So let's look at this example. Suppose I have a 2 by 2 that I want to multiply by a 2 by 1. Well, since I've got 2 columns in the first matrix and 2 rows in the second, I can do that. And what do I end up with? A matrix that has 2 rows and 1 column. So a 2 by 2 times a 2 by 1 gives me a 2 by 1. All right, so if it's a 2 by 1, then I actually have 2 slots. This one and that one. So I look at this slot. I notice it is what? First row, first column. So that's what I do. I take the first row and I multiply it by the first column. Now, how do I take a row and multiply it by a column? And the answer is I do it. I multiply the corresponding elements and add. So it's a 1 times a 5, add a 2 times a 6. So 1 times 5, add 2 times 6, that's what I get in the first slot. This element here is what? Second row, first column. So that's what I do. I take the second row, I multiply it by the first column. How do I multiply a row by a column? I multiply the corresponding terms and add. 3 times 5, add 4 times 6. So I get a 3 times 5, add 4 times 6. When I clean up this arithmetic, that's going to give me a 17 here and a 39 there. And that's the way I multiply two matrices together. I'm going to stop there.